Hi, good afternoon, everybody. If you could hear me, just say good afternoon in the chat, and if you could see the screen, um, yeah. So once you could see the screen and you could hear my voice, just say good afternoon, and then we're gonna get started. So something I need everybody to get. I need you to get a blue book. I need you to get a blue book. I need you to get a blue book. I need you to get a pencil or pen, right? Um, because we're trying to maximize today's session, which is going to be focused only on the formulas that you need to know out your head. So if you didn't know what you needed to know before, after today, if you realize you don't know these things out your head, these are the things you're going to be focusing on. All right. So once you're ready, say ready, and then we get straight into it. So, like I said, today's session is focusing specifically on all the formulas that you have to know out your head. And you should know when to use it, why to use it, how to use it, all of that. So one person said they're ready, just waiting on 12 others to confirm that they're ready. Today's Tuesday. The exam is Friday morning. I hope you guys are working hard. I hope you guys are putting in the work because you have everything that you need to know. It's just for you to revise, practice, all of that good stuff. All right, so we're going to go backwards. So we're going to start from question 10, which is matrices and vectors, right? And then I was trying to finish the slides, but I didn't finish, so I'll try to finish today. All right, so let's get started. As we know, when it comes to matrices, the first thing that is extremely important to this topic, let me just zoom in here, and nobody should be writing right now. You are going to tell you what you should write and when you should write. But for now, make sure you're paying attention and you're focusing, right? And trying to memorize. So the first thing we need to know about matrices is that the order, what order means. And order means the number of rows by the number of columns. So for example, in this one, this would be a 2 by 2 because rows go across, columns come down. So this would be a 2 by 2, this would be a 2 by 2. Right? The reason we must know this because in order for us to determine whether two matrices could be added, we need to know the order. In order to determine if two matrices could be multiplied, we need to know both of their orders. Okay. So when I'm moving through, I'm gonna ask every 3 points. I'm gonna ask if you're okay, and then you just confirm. So we know what order is, right? Let's go. Everybody confirm quickly. Remember what order means. Remember how to find it. Remember how it's important. All right, next one, addition. We should remember in order for us to add two matrices, they must have the same order. Why? Because you can only add the terms in the same position. So here, this is position 1. I could add A and P. Position 2, B and Q. Position 3, C and R. Position 4, D and S. So if I was to add two matrices, that's how I would add them. I could only add those in the same position because they have the same order. And next thing you need to remember is equal matrices. So we did a lot of practice of this. So if two matrices are equal, that means the terms that are in the same positions are equal. So A is equal to E. Now keep in mind, how does this come? Sometimes they might say X plus 2 is equal to 5, and 5 is here. Then they're going to find what X is. Because A and E is equal, that means X plus 2 is equal to the same thing as 5. And what do we do here to find X, everybody? Quickly. Transpose. Everybody with me? And we should know how to transpose addition and subtraction. And another thing is keeping in mind that algebra is in everything. So if you know you're not strong in transposing and solving, please practice that between now and Friday. All right. So everybody, if you got it, say got it. And this is what I'm talking about when it comes to the equal matrices. You know what it means for two matrices to be equal. So, you know, whatever they say, solve it, right? Sometimes it would have an addition on this side in a multiplication. It doesn't matter. You add them first and then you just solve based on the positions, right? All right. To multiply two matrices could be multiplied if the number of columns in the first matrix, which is the second number, is equal to the number of rows of the second matrix. So you see, that's why these two middle numbers must match. So you should never, when multiply two matrices before what? Making sure that you check that it could be multiplied, right? So that's the first thing. This is the thing that you must draw first. Then what this also tells you is how your answer going to end up being. So the two end numbers would tell you what type of matrix your answer is going to be. So you should remember how to multiply two matrices, right? What is the rule? The rule is rows multiplied by columns. So everybody should remember you should map out your number of spaces. And you know you got your different positions, top left, top right, top, bottom left, bottom right. And then you use the combinations to multiply. If you remember these things, say, got it? And I'm watching the chat. Talk to me. Please do not go in the exam not being strong in multiplying matrices. And to me, I'm going to be honest with you, that's going to be extremely ridiculous. Because it's something we've finished long time. It's something we've practiced several times. So that's something you have to make sure you could do, because if you can't multiply two matrices, you can't answer no other question. Okay? So if you know you're sitting on right now, you know you don't know how to do it good, you have a responsibility to go and practice now. All right, so we're moving on. How do we use multiplication? Now, in order to answer questions, we're going to have to be able to know what a determinant is. And you could only find the determinant for a 2 by 2 matrix. And we should remember the determinant have a formula. What's the formula for the determinant? And just keeping in mind, what does determinant also mean? You see this, the two dashes, and we should also remember that these two dashes have a meaning in vectors. So this means one thing in matrices, and this means something else in vectors, and we got to keep that in mind. So as we know, this is the element A, B, C, D in that order. So to find the determinant, what's the formula? AD minus BC. Everybody say it out loud. AD minus BC. That's how we find what? The determinant of a matrix. Now, what is important about the determinant? If they say a matrix is singular, we should know what that means. If something is singular, if a matrix is singular, it means that the determinant is equal to 0. That means this formula is equal to 0. So sometimes they might put X here and another number here, and it might say solve for X. Once they tell us it's singular, you know the answer is equal to 0, and you transpose to find the answer. If you got it, say got it. Because we've done several examples using this. We've done several past paper exams talking about this as well. So we know singular mean determinant of the matrix equal to 0. And that information is useful when trying to solve or trying to find something that they ask you to find. Okay? All right, moving on. Adjoint. We should know how to find the adjoint. How do we find the adjoint? It's 2 steps. You switch A and D. Sorry, not switch A and D. Yes, you switch A and D. So this is a mistake. So D gonna be up here and A gonna be down here. And then you multiply B and C by -1. Right? So let's go again. How do we find the adjoint? Switch A and D, multiply B and C by -1. Okay? Again, things you should know. Formula for inverse, which is probably the most important one. How do you find the inverse of any matrix? 1 over the determinant of A. So that means if you're finding the inverse, you know, you got to find 2 things first. What you got to find? You got to find the determinant and you have to find the adjoint. We've done several practices of this. So what is the formula? 1 over the determinant of A times the adjoint of A. This is something you have to memorize, okay? This is something you must know. If you got it, say got it. And I only seeing the same people saying got it. One to everybody else. Dante ain't answer yet. Arabo may see you. Who else? Whoever is Lahira's phone, Rainbow, Rikayo. You have to answer for every question. Trev, whoever is dot, dot, dot. All right. Now, simultaneous equations. What do you have to remember about simultaneous equations? You have to remember how to extract the formula. So when they give you simultaneous equation, you get this formula from it. So I'm just going to do it quickly. So suppose I have 3x minus 2y equals 6, 5x plus 4y equal 9. How do I write this into the first formula, which is ax equal b? Because you can't do nothing unless you have this first. A is the coefficients of the variables. So the first matrix that I'm going to have, ax is equal to b. A is the coefficient. So what is the coefficient here? 3, -2, 5, +4. What is x? X represents the variables. What's the two variables we're dealing with? X and y. What is b? B is the solution. So that would be 6 and 9. Then, where do you go from here? You should remember that if you're solving simultaneous equations, you're actually trying to find x. You're trying to find what x and y is. So that's where you get a new formula, because you're going to transpose this. So this is the formula you actually need to make sure you memorize. Also, x is equal to A inverse B. So how do I find this? We find A inverse. We got A, look A here, and you should know how to find A inverse because it has a formula. Watch it there. Times B. So whatever that answer is, it's always like a fraction. So it's like a half. You leave the half out so that you don't have to deal with a fraction in here. So let's say our answer was 6,529. Sorry. And then you know B is what, 6,9. So you multiply these two, you get your answer. And then you apply the half last. If you don't know what I am talking about, that's really your problem. And I'm going to be very honest because we've done this a million times. Every time we revise matrices, we make sure we do a simultaneous equation. You have examples in your notebook. You have examples in the blue book. So if you know you don't know what I'm talking about, you're watching this and you're lost, that's your problem. Go and revise it on your own. All I'm doing is making sure I just recap the steps because I know I've taught this to you. If you got it, say got it. If you choose to get a full night's sleep and not study, if you choose to do everything else except study, you are the only person responsible for your performance based on how much work you put in. So please do not take this lightly. Try to study as much as possible. All right, so basically, this first half is what majority of the questions will come like. Okay, once you know everything on this side, you know, obviously there's variations of these things, which you would see when you go over your past paper compilations. And what do I mean by that? You remember last week, every class was dedicated to a specific question. So we had a class, we did only question 10, only question 9, only question 8. So your job is to make sure you have this information while you're recapping those questions. So you remember, oh yeah, this is what this means, this is what I mean. All right, so now the second half of the matrix question could be matrix transformation. Well, this part involves the calculation part. So the first thing we need to remember is the different types of transformations. What are the different transformations? We have translation. What does translation mean again? Translation means when it's sliding left and right. But you know what's important here is the formula. And it's only two formulas. Translation is the only one that is an addition formula. How does it look? Anytime they give you something with an X and a Y. Right or wrong? Because when X is positive, what type of movement is that? A right movement. When X is negative, what type of movement is that? A left movement. When Y is positive, where do we go? And when Y is negative, where do we go? One to everybody else. One to everybody else. So don't forget, this is the formula. You should know what M prime mean. M prime mean, and you don't have to use M, you could use P. Any letter they give you to represent the transformation, you use that, right? So the object, the image is what happens after it changes, is equal to the object plus the translation. So this is the formula you must remember. So once you see they give you this matrix here, you know it's a translation automatically. When it comes to reflection, rotation, and enlargement, once you see they give you a 2x2, you know it's either one of them. And we've done exercises where I've taught you to know whether it is a reflection in the y-axis, reflection in the x-axis, reflection in the y is equal to x line, reflection in any line. We've done that, right? So these are things you need to be mindful of as well. And this is the formula. This is the multiplication one. So translation is the addition. Reflection, rotation, enlargement is the multiplication one. Transformations always come first. So if you want to calculate M prime, the transformation got to go in the front. Everybody with me? So let's take a look at how these transformations, matrices does look. The first one you need to memorize is this one, because this one is the identity. What does the identity do? The identity does not change the matrix. It stays the same. It's like multiplying by 1. So just checking in here. Everybody remember when we did this class? Y'all should have all of the drawings in your book where I show you where it's going to end up. And I teach you how to do it. Like if you don't remember, you could sketch it in your book. Like you see how I choose a 0.34? I will see what happened after I do 3, 4. Yeah? Okay? All right. So let's look at the second one. What do you realize with the second one? It's the same thing like the identity, which means the number's going to stay the same, but who becomes negative? Remember, the top numbers are always what? The top numbers are always, anybody could tell me which one is the top number, X or Y? X, and the bottom number is always Y, right? So if the bottom one is negative, that ain't mean the Y term gonna become negative. Because remember, this is your X and this is your Y. This is your X and this is your Y. So this kind of tells you what happened. Now, when you notice, you realize who became negative. The Y became negative. So that means this moved from the top, gone down to a negative Y. So obviously, what type of reflection is that? Is the reflection in the x-axis. Okay? Everybody's with me? Because they're going to ask you to describe what happened to the point. Or they're going to tell you, and you got to be able to know what you're supposed to be expecting. Okay, so let's look at this one. What you notice about this one is the same thing as the identity, but who is negative now in this one? The X. So now that means I move from positive side X to the negative side X. So obviously this is a reflection in the Y-axis, because if I was over here on the X side, positive, and I gone over here, that means that I have now become a reflection in the Y-axis, right? So don't let these things punk you. Remember, I teach you different ways to kind of cheat the code. So let's say you can't remember what a matrix means. If you do a little sketch graph, you could figure out where it went, where the point moved to, and based on where the point moved to, you could kind of guess whether it was the reflection or whether if it was the rotation and all these things. Everybody with me? All right. So the next one now, what do you notice here? You realize this switch now? So once it switch, this is a reflection in Y is equal to X, and everybody should know how that line look. How that line look? Y is equal to X, that in the diagonal graph. Everybody see that? Once you see this switch and Y is equal to X, the name of this line is called the diagonal line graph. And everybody should also know that there's the negative version of it. So that means I'm going to use the yellow to represent the negative version. It gone this way. So the positive gone this way, the negative gone this way. So everybody see that? Because who became negative? Both the y and the x became negative. All right, so everybody okay so far? Because we moving along. All we're focusing on is formulas that we need to know. I'm taking a pause to get some feedback. All right, so when it comes to the translation, how do we know the translation work again? We know if x is positive, that's right. X is negative, left. Y is positive, up. Y is negative, down. Right? I like to hear that. I like to hear that. Then we know the rotations, right? Once one of them is negative, we know. How do you describe a rotation? A rotation, you must state what? The angle, the direction, and the point of rotation, right? The origin, the point of rotation. So we know when, if it gone this way, is if, let me just show you what I mean. So this is our Cartesian plane. If you gone from one quadrant to the next quadrant, what angle is that, everyone? If you just move over to the next quadrant, what angle is that? That's 90 degrees. If I move 2 quadrants over, what angle is that? Excellent. And if I move 3 quadrants over, what angle is that? 270 degrees. Excellent job, everyone. Even though it's right here, right? Because we did this. And then the last one is the enlargement and the remember, enlargement could mean getting bigger or getting smaller, right? So, for example, if K is positive, we know that you're going to get what? Bigger. And if K is less than 1, we know you're going to get smaller. So, for example, if I have this, what does this mean? This A means it's going to multiply by 2. Because compared to the identity, everybody see that? That means this is times 2 to get this. Agree or disagree? Talk to me. So that means this is an enlargement by twice. That means the shape double in size. Suppose there is a fraction, guys. If it's a fraction, what I mean? That it gets what? Instead of bigger, it gets what? Smaller. And it gets smaller by half, right? All right, so let's just quickly recap everything we got here to make sure we're on the same page, because that's all we're doing right now. We're going over everything for the exam from beginning to end. So if you sitting down and you feel like, wow, I know all of these things, that means you're in a really good position. If you sitting down here and be like, man, I forget all of this, or may remember all of this, that means you got to do some work after this class, whether you remember or not. You see the blue book? The blue book has all of this plus examples right next to it. So honestly, make the blue book your friend. The blue book have everything you need to know. So we know what order mean. We know how to add 2 matrices. We know what condition must be met for you to add the 2 matrices. We know what equal matrices mean. We know how to multiply 2 matrices. And I need to make sure everybody, make sure you practice this. Make sure you practice multiplication. And that's what I need you to write down right now. Because as we noticed, that was a weakness of the class. A lot of people were struggling. So when it comes to this topic, I need everybody to practice multiplying. If my pen would give me a break. Even if you're good, don't go sleep tonight without, because this gonna be on the list of things you got to do after class. My pen kind of spazzing. Everybody understand what I'm trying to say? That this is the key skill of this question. Make sure you could multiply 2 matrices. Make sure. If you can't multiply 2 matrices, you can't find the inverse. You can't find the inverse, you can't solve simultaneous equations. You can't multiply you can't multiply translations or transformations. Want to everybody else, talk to me. So this is the key skill for question number 10 for matrices. So that's what you're writing down for me now. This is what you must do after today's class. You must multiply and make sure you use different examples from your book. You have your examples and you got your answers. So you do one, pick one, you do it again, on a scrap paper and you go back and make sure you got the right answer. If you didn't get the right answer, you pay attention to what mistakes you're making so you could fix it. All right, so that's matrices. If everybody was to give me a score, because I need to write this down. Tomorrow is our last face-to-face class. I'm gonna try to make sure we have class face-to-face tomorrow. You should be feeling way better. Should be feeling way better. So, what I need now is everybody for this topic, 10. Give me a score out of 10 now, please. Be honest, because telling me a lie ain't gonna help. So I could know where tomorrow, what areas I gotta focus on the most. That's everybody. All right, so now we're gonna move on to vectors. All right, so vectors, these are the key elements. If you're ready, say ready. Okay, when it comes to vectors, remember you gotta think of it like a puzzle, right? Remember a vector, what are some important concepts about the vector? It must be a direction because remember the direction can tell us if it's positive or negative. Remember that? Then there's two types of vectors we must know. The first vector is the position vector, and the second one is the displacement vector. We should remember that the position vector starts at the what? At the origin. How do we know a vector is the position vector? It starts with a O, right or wrong? Because it starts from the origin. I could represent any point as a position vector. So if I tell you point P is equal to 3, 6, what is the position vector? All you got to do is write it out vertically. Everybody remember that? So you could change a point directly to a vector because it is called a position vector. It's from the origin. Can I do that with a displacement vector? So I know OP is equal to this. Can I do that with a displacement vector? No. To do a displacement vector, and what's a displacement vector? Any vector that does not start at the origin. What do you need for a displacement vector? You need a triangular law. So this is something I need everybody to confirm. Everybody remember the triangular law, how to create the triangular law, how do you manipulate vectors to make your own law to find whatever vector that you need. Remember, we practice this a lot of times. I watch in the chat. This is something students forget when they're nervous. You can't forget these things. Okay, so let's look at vector representation. You could represent a vector using 2 capital letters. You could represent, okay, noted. You could represent a vector by 2 capital letters. And what does this mean? What does this signify? This tells us our starting point and our ending point, ain't it? This telling us where we're starting from and where we're going to. So this means we want to go from A to B. Another representation is a common letter, and this is usually called our vector equation representation. We use a common letter. And then the third one is using a column vector, which tells us the movement. So this tells us what type of X movement we have, what type of Y movement we have, right? So what do we also know? If O to A is small a positive, A to O is what? The negative version of that, because it is in what? The opposite direction. So everybody confirm that you got this. If you got it, say got it. Sorry. All right. So displacement vector rule. So look at this. O is the origin, we know. I want to go from A to B, but there's no direct vector at the moment. So where would I have to go? I have to follow my pathway, right? So you could draw it, you could use your diagrams, you could even put your formulas together. I have to go from A to B. So what's the beginning of my formula? My formula must start with A. Everybody see that it must start with A and it must end in B. But they must have a point in common. And in this case, what is our common point here? Our common point is the origin. So let's go. So you're going to go from A to O. And because that's the opposite direction, this is going to be what? Negative A plus O to B. And that's positive because it's going in the same direction. So that's how, this is what we call the vector equation. The vector equation uses what type of letters, everybody? The big or the small? So the first thing you always have to do is write out your formula, because your formula tells you what pathway you need to take, and then you pay attention to your directions. So when you pay attention to your directions, you will know, is it positive or is it negative? Okay, everybody remember this? Everybody okay with this? Talk to me, because at the end of this, I would like us to go over the January exam, and you know why? The January exam tends to be a reflection of what could come in June. It's not always, but if you can't do the January exam, I'm telling you now, that is an indication of how you would do in the June, right? And I would have looked at, I didn't mark it, but I would have looked at everybody's paper and I would have seen some of the strengths and weaknesses that you guys have. And tomorrow we're going to address those weaknesses on a general base. I'm going to talk to everybody one-on-one to kind of give you some advice based on what I saw and based on what I know about you, what I think you should do as your last resort to try to get it together. And then remember, we have no class on Thursday. So Thursday, you are responsible for doing everything I asked you to do plus me. Everybody understand what I'm saying? If you choose to come to the sessions, you choose to come to the sessions. If you don't come, you don't come. At the end of the day, you got to know what you want for yourself, right? But what I would tell you guys is one of the things I've seen that works is that you don't give up. Even if you ain't sure what to do. And that's why I try to always push you guys to think. Just figure what you could write that would make sense and see what you could work with it. Okay? All right, so let's keep it moving. So far, we know what the position vector is. We remember how it looks. We remember how to get it. Two, please note also, you could make a position vector from, no problem, because I know people have exams. Like I know this week they have accounts and other different exams this week. I think INTI. Yeah, so it's okay. Just message me if anything, okay? All right. So like I was saying, so please note that you could also even calculate a position vector using the um displacement law. So for example, suppose I ask you to find AO from, you got AB, you got OB. Who could tell me how do I get AO, OA from this? What's the formula to get AO from these two? I want OA, but I have AB and I have OB. How do I create OA? What's the combination? You're close, but you're wrong. You know why you're wrong? Who should be in the front? Who should start it? One to everybody else. That's it. OB got to go in front because we want to start with an O. So it's going to be OB plus BA. Because B must be in the center. And what should start it? The O must start it because that's what we want in the front. And who must end it? The A must be at the beginning because that's how we want to end it. Everybody see that? If you understand what we just did this, just make sure you indicate so by saying yes or got it. If you ain't know what we're talking about, guys, get on top of it. Okay? Remember, your knowledge is what gonna help you piece together what to do. All right, so let's keep it moving. Column vector, again, you realize it's the same thing again, even though we're doing vectors, it's the same thing as matrices. X is always to the top, Y is always to the bottom. If X is positive, that's a right movement. Sorry, I'm feeling a little bit weak again. Just give me a minute. Okay. X, when X is positive, X is a right movement. When X is negative, X is a left movement, right? Y is positive, Y is up. When Y is negative, Y is down. All right. So if you are trying to figure out where, because remember, everybody remember, you got two ways. You got a calculation way and you got a graph way. Let me know if you remember all of this in our books, by the way. Remember, we practiced all of this. We did both of them. So sometimes the vector question, they will give it to you on the graph and you have to count how much boxes to the right, how much boxes up, how much boxes down. Yeah, remember that? So make sure you be mindful that you could calculate this or you could use the graph to do it. It's the same thing, it's just two different representations, okay? All right, so let's look here. The length of a vector. Be honest with me, how much people remember this formula here? Remember, this is the next meaning of the two lines. So remember, in matrices, this means what? What this means in matrices again? Sorry. When we see these two lines in matrices, what does it mean? Thank you, determinant. But yeah, we gotta know these things, guys. And I literally just pointed out 10 minutes ago. In matrices, these two lines mean determinant. What's the formula for determinant again? I'm watching how fast I respond because that's saying a lot about your dedication to memorizing things. What's the formula for determinant again? AD minus BC. Thank you. Oh, before I continue, anybody got the email? No, one over the determinant is the formula for the inverse, Dante. The determinant by itself is just the AD minus BC, okay? Don't get them confused. Anybody got the email from the exam committee? Have y'all checked your emails? They sent an email yesterday, last night, saying that they add in everybody who doing exams to a group chat. And the group chat gonna tell you where your exam is gonna be. They say all the exams is at the college, so you ain't gotta worry about. You have to add yourself based on the email they sent. So after class, I am going to send y'all the link to add yourself to the email because that's what they're gonna post, which classroom of the college you're gonna be in. So let me just get an idea, yes or no, if anybody got it. Because they said they sent it out to all candidates. No, okay. It's very disorganized this year, guys. Trust me, it's a hot mess. Usually students already have an idea of the list and they didn't even have the list yet. Regardless, once they send it out and I get it, I will just post it in our group chats or forward it. So, but everybody has to be of the college. And I think they say, if not the college, it's going to be Tech Fac, which is just down the road. But they say, I think everybody should fit up the college. I think, yeah, up CFBC. So you don't have to worry. It's not going to be at AVEC or any other location. So, yeah. All right, so let's get here. So this formula means the length of the vector, the size of the vector. Another word for size, so I'm just going to write these words. So if you see it, you know it's the same thing. Magnitude means how big something is. Size or length. So all of these words mean the same thing. And what's the formula? The square root of x squared plus y squared. Make sure you know it. No problem, Lovine. All right, so vector parallelogram. So we should know what parallelogram means. So if this is positive A, on the opposite side of the parallel side is going to be A as well. So if CB is positive A, what is BC, everybody? BC would therefore be the negative A, right? Same thing with AB and DC. So once you remember what parallelogram mean, you should be good to go. That's just the basic concept there. So once I could find this line up here, that means I know this line here. How we looking so far, everybody? Everybody okay? Okay, all right. So let's go down here. Now, this is the part that we spoke on, we practiced a few times as well. Remember the rule? Prove vectors are parallel. So if they say prove that these two vectors are parallel, you have to make sure that you're sure that one is a multiple of the other. Now, even though some of them come in fractions, I teach you a trick about doing that, right or wrong? Everybody remember that? So if, let's say, one vector is A plus B, and then another vector is half A plus half B. Are they parallel? Everybody, yes or no? Excellent, because what did I teach you to do? You have to factorize first, right? When you factorize, you take out a half because they have a half in common and we're left back A plus B. So obviously here it is the same, except it's multiplied by what? A half. So that means K is a half. And once you could find K, therefore they are what? Parallel. And the reason why I use a half is because K don't have to be a whole number. K could be a fraction. Everybody with me? Because this one would be obvious. If I had gotten 6A plus 6B, that's obvious because obviously K is equal to what? K is equal to 6. So it's the same concept if it is a fraction. Okay? So look, it says here, if two vectors are parallel, they are scalar multiples of each other. So if AB is equal to KCD, where K is a scalar constant and AB is parallel to CD. And I taught you how to write your sentences. So you literally, this is the sentence you always write. If AB or whichever letters they give you is equal to K, therefore they are parallel. And you have to state who K is. If you got it, say got it. All right. How do we prove if 3 points are collinear? That means if 3 points are on the same line. So look at this example here. The points that they gave us is A, B, and C. How do we prove that A, B, and C is collinear? We know if we put them on a straight line, how much vectors on this line here in all, guys? How much vectors in all here? One, two, three. 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 What's the vectors on this line? Vector AB, vector BC, and vector AC. Tell me if you're seeing it now. Everybody see that? So what they're saying, if you use these 3 points to make vectors like this, and you could prove that AB is equal to KBC, that means all 3 of them is what? On the same line, aka collinear. So everybody see what you got to do? You got to calculate AB, you got to calculate BC, and prove that one is a multiple of the other. Everybody with me? That ain't almost the same thing as above. It's the same thing like above, except above, they give you the vectors, so you just got to find if it's a multiple of each other. But down here, because they give you the points, what do you have to do? You have to make the vectors. Everybody see that? Everybody with me? So that's it. That's it for vectors. The only other thing is if they ask you to find the vector equations, and we did that already. So if they give you this funny shape, and they say all of these points go, sorry, but I just feel so sick. I'm tired. Okay. Anybody remember these questions when they would tell you like this line is a half or midpoint or a third or y'all remember those questions? That's the hardest part about it. So all you just got to remember is if you want to find AC, you look for the pathway and you follow it. And then, AC, therefore, whap, 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 whap. So we did all of this before. So just revise those harder questions so that you could mentally prepare on what you're supposed to do with it. But outside of that, it's pretty straightforward and pretty simple. So that's the end of question 10. These are the formulas that you need to know. All right, taking a screenshot of these things of the screen. But I expect my students to know that, like, that would be the smart thing to do, no? Hello, everybody else? Because if you're not doing that, you know what you're doing there. Because I can't get this printed out in time for tomorrow. So you should be saving my screen. All right, so let's move on. Question 9. What question 9 involves again? Question 9 involves what? Circle theorem, trigonometry. So, Pythagoras theorem, trig ratios, sine rule, cosine rule, bearing, angles of elevation and depression. Everybody with me? So how did I teach you to answer all these questions? What's the strategy for question number 9? Do you read the question first or you try to find all the angles by yourself first? You look at the diagram first. You make sure you could understand, find all the rules, then see which angles you could find by yourself. You're writing with your pencil. And then you go back and you read the questions and you go from there. Okay? So let's go. Let's go to these rules. Again, we drill this to the T. So if you don't know this, you got to learn them. This one is what angles in the same segment are equal. And what we call this is what? Twin angles, right? Next one, angles at the center is twice angles at the circumference. Angles in a semicircle is, I'm watching the chat, asking a question now. Angles in a semicircle is what? 90, very good. Opposite angles in a cyclic quadrilateral add up to? Good. The angle between a tangent and a radius is always? If two tangents meet at a point, what do we know about those two tangents? They have the same length. Yeah. And in this one, the external angle is equal to the what? Internal, not just the internal, but the internal opposite. The only thing that's not here is the isosceles triangle. Everybody remember the isosceles triangle? The properties of the isosceles triangle? And how do we know something is the isosceles triangle? If this is a radius and this is a radius, because if this is a circle, let's pretend this look good, right? So if this is a radius and this is a radius, we know that this is automatically what? An isosceles triangle. And that means the angles at the base are what? These two angles are what? All angles in a triangle add up to? Good. We're looking, at least you are looking good with the angles because I think we really drill this a lot. We drill this a lot, yeah? So let's go to the rules, everybody. When it comes to right angle triangles, what's the only two rules we could use? Use the short words for it. Only two rules we could use for the right angle triangle. What's the two rules? It's either do it in the order that I teach you. What's the order that I teach you? Which is the first one you should be thinking about first? Remember, that's the reason I teach you in a certain way. So you store the information in your mind in a certain way. The first one you're going to think about first is Pythagoras. When do we use Pythagoras again? Only if you're dealing with what? Only if you have two out of the three sides. So that's how you find the third side. Everybody with me? And you have to memorize this formula. It's not on the formula sheet. So what's the formula for Pythagoras? C, which is the long side, is the addition version. And A is the subtraction version. And that's for what? The short side. Everybody remember that? Oh, you give me a minute. I'm feeling like dizzy. I need to go get some water. So take some time. I'm gonna open up the screen and you're gonna just look through this for a little bit until I come back. Okay, I just need 2 minutes. All right, I can see it good? Or should I zoom out more? So just recap that quickly. Give me a minute. All right, guys. No problem. All right, everybody with me? If you're here, say here, and then we get back into it. We're watching to confirm to see who are here. Okay, good. All right, let's go, guys. So as I was saying, right? Okay. So the first thing you do when you see a question is you're looking at what type of triangle you have. And if it's a right angle triangle, there's only two rules you should be thinking about. If the triangle have two sides and the question asks you for the missing one, you have to use Pythagoras, right? If the triangle has sides and angles, and they ask you to find a missing side, you have to use what? What do we use here? We use tricks. Then we should also know the different relationships. So you know how to identify who's the opposite. Remember, the opposite is on the opposite side. Let me ask a question. Everybody okay with that part, right? Knowing who is the opposite, who is the hypotenuse, who is the adjacent. Everybody good with that? Okay, good, right? So that's your skill because you can't answer the question without knowing that because you could get it wrong. So make sure you got it unlocked. And then we should remember You got the sine and you got the inverse. We use the inverse if they ask you to find the missing angles. Everybody see? And we use the cos and the sine and the tan to find the missing sides. We use these rules for angles of elevation and depression. So let me see if I could just take a look at this. So let's look at this. Everybody remember angle of elevation and depression? So let's just zoom in here. It's two options you could be drawing. If it's the angles of elevation, this is how your triangle gonna look. It's gonna just look like a regular right angle triangle, yeah? If it's an angle of depression, how is it gonna look? Like the Z. Everybody remember that? Clock it, clock it. So I'm gonna zoom in so we could remember the properties. If they ask you for the height of anything, I'm going to label each side. So this is usually a C. Let's call it C. This is your A and this is your B. It's only two different things they could ask you for. If they ask you to find the height, which side going to always be the height? A, B, or C? I want to make sure we're on the same page because these are the things people tend to get confused by, right? Good. A would always be the height because A is the perpendicular distance from the base. So if they ask you for height, you know, this is the side you're paying attention to. And in this case, what side is A? The opposite or the edge? Excellent, because it is on the opposite side of the angle. Very good, guys. And then if they ask you for the distance between, which line is the only line that could give you the distance between two things? It could only be B. Everybody with me? So you should know which line you're looking for based on what the question asks you for. And that's the only two questions they could ask you for. Because C is the line of sight. This is where the person looking. If they ask you to calculate how far is the line of sight, that's the only time you're going to find the hypotenuse, okay? So let's move on to, and obviously what type of triangle they're using here? A right angle triangle. So it's only trig ratios you could use to solve. And if they give you the two sides, you could use what? Pythagoras. Everybody with me? Then we have the angle of depression. What's the thing I need you to remember? Remember alternate angles, the Z angles. If this is B and this is A, that means these two are also what? Equal. So that means the angle of depression is the same thing as the angles of elevation. So if this is 20 here, what is this angle in here, everyone? 20. And as we know, again, we have our height and we have our base distance. Okay? Use trig ratios to solve. All right. Now let's go to bearings. What is the important things we need to know about bearings? When we deal with bearings, remember bearings is different from angles, right? Bearings use how much digits, everybody? If they ask you to write a bearing uses 3 digits, but angles uses 2 if necessary. Another thing we need to remember is that where do we know where we draw the knot line? The knot line always goes at the from location. From A, so that means the knot line is at A, right? What else do we know? The angle is measured at a clockwise direction from the knot line. So if I want to know the bearing of B from A, that would be 060. Yeah? Some numbers that we need to know. If a location is east, that's an automatic bearing. East can always be what? East ain't always going to be 090 because it's 90 degrees. Everybody see that? South will always be what angle or what bearing? 180. West will be always what? 270. If you got it, say got it. Something else that we have to keep in mind. Remember, we learned certain things. If I have two bearings, so let's call this P, let's call this Q. What's some properties that we know? So this is a knot line here, this is a knot line here. What do we remember about these two angles inside here? Both of them is what? What we call this? This is co-interior. So that means P plus Q is equal to what? Excellent. Everybody remember that? Do you also remember that if I know this, so let's say this is 100, don't I know what out here is? Yes, because all angles at a point, all of it must add up to all of it must add up to 360. So it's a 360 minus 100, and that would give you the bearing from M to Q. Everybody see that? Something else I want us to be mindful of is suppose, right, we have another bearing going this way. So we know the bearing from here to here, and we know the bearing from here to here. Don't that mean if I had to connect this to make a triangle, that a mean I know this angle inside here? Anybody remember that? So you're going to take this big angle. So let's say this big angle is 300. Let's say this bearing here is 100. What is this angle in here? How do we find this angle in here? We say the big bearing, which is 300, minus the short bearing, which is 100. So it's going to be 200. Look at it, you see, because 100 plus this ain't going to give you the full thing. Everybody remember that? Because we did this as well in class. I think you was absent, Lovey, during you was absent when we did this focus. I think so, but come on, everybody, talk to me, talk to me. Because look at it. This line and this line together and give you this full line out here. So that means 100 plus this P angle must give you the 300. So you subtract it to find the angle in here. Everybody got with me? What other rules we need to remember? The cosine rule and the sine rule. The sine rule and the cosine rule are on the exam paper, but how do you know when to use the sine rule? When the angle is not, because sin is bad, right? So if the angle is not between, you use the sine rule, or if you got two angles on one side. If you got it, say got it. When do we use the cosine? If we got two sides and the angle is between, or if we got three sides. What type of triangle this is for? This is for the triangle that is not a right angle triangle, yeah? Also, everybody remember this rule? If this is angle A, that means this is side A. If this is angle C, that means this is side C. If this is angle B, that means this is side B. Remember when you're dealing with your substitution, you gotta make sure it's matching. Yeah, I remember when we was practicing the question, that was the mistake I was making. That y'all forget that it must match. So you just can't assume that this is side A and this is side B. You have to use the rules. Talk to me. That's the mistake y'all was making. Y'all were just assigning any letter to any letter. No. So for example, if I am looking for side A, that means the only angle I should be cosing is angle A. Everybody see now? All right. So we're cooking on gas so far. So that's question 9, guys. That's question 9. So let's just quickly recap again. All the laws for circle theorems. What is our strategy for this? Our strategy is when we see a question, we look for all the rules that we could see. Is it angles at the centers, twice angles at the circumference? Is it the external angle equal to the internal opposite? Is it angles in a semicircle? How do I know something is in a semicircle? What line we must find? We must find the diameter. Yeah, guys, I need to take a short break again. So I need 5 minutes, but I'm gonna give you the next slide that you should be focusing on. So when I come back, we jump straight into it. Look at this so long. I have to add some stuff to this. But everybody remember when we did the time graph? Everybody remember the minimum and the maximum? So just take a little minute to go through this. And this is for question 8. If you missed this, I'm gonna try go over this tomorrow then. I think I'm gonna go over question 8 tomorrow because in addition to this, I got some things to add. So this is where we might do some writing because I gotta add some stuff here. But for now, read everything here. Don't study this part. Don't study this part. Don't study this part. I was going to introduce this, but no, I'm going to just go to how we did it. So don't study this part here. Just study everything else. Especially the time graph thing. Give me a minute. I'll come in. All right, guys, I'm back. Apologies. Just type ready if you're here with me and ready to continue. Also, but let me just wait till everybody start responding. Um, yeah, for class today, it might just require me to do that every half an hour. That's okay? Yeah, that's the only way I think I could get through like class today, by taking those breaks. So, all right. Okay, let's go. We're ready again. So where I would like us to begin with this is this concept here, right? Let me just pull up the notes for this. Remember, everybody, I had this handout, this little booklet, the booklet handout. Talk to me. Everybody remember the booklet that you should have with this, with quadratic functions. Keep that close. That's actually very important. That is actually very useful. It's summarized already. Everything is on the front page. Everything you need to know about quadratic equations is on the front page. And then remember all the stuff behind was examples. So these are the things that we need to remember from that. If they give us a quadratic equation, everybody remember the quadratic equation, the general formula, ax squared plus bx plus c. And we know A is the what? A is the coefficient of the x squared. Don't forget, it doesn't matter if it's in different positions. So let's say the bx was in front. It doesn't matter. A comes from the x squared. B comes from the x. And what is C? C is the constant. Everybody with me? If they ask you to write the quadratic equation in this way, what is the way? This form, ax plus h square plus k. We did a shortcut way. Remember, I was telling her I don't teach this because there's a lot and people don't tend to get it, or it just be a lot. It just take up like maybe a week or two. So I taught you the formula way, where there's a formula to find h and k, because we know what a is. A is the coefficient of the x squared. Also, we remember this. If a is positive, that's the minimum. So that means it's going to look like this. If A is negative, it has a maximum. Remember, it's the opposite, right? So you're going to look like that. Everybody remember that? That's also important, yeah? Okay, so even though it's kind of here, it's here, but we still got to remember the formula for these things. So H have a formula. The formula for H is B over 2A, and the formula for K is 4AC minus B squared over 4A. You need to remember this. I think I told y'all this already. Yeah. And from this information, this usually represents your X value. This represents your Y value. So not negative Y, your Y value. And these 2 points, when you put them together, it represents here where your axis of symmetry is. And why is your axis of symmetry important? Because it's going to give you your Y, either your minimum or your maximum point. Everybody remember this now? But it's negative HK for the maximum and minimum point. So even though I have here X and Y, here it is, if you look in your textbook, you would realize that the axis of symmetry is negative B over 2A. So that's why this is going to become negative H and positive K. Okay, for the maximum or minimum point. All right, let's look at the conditions on the graph itself. So first of all, we know that these two means the roots. That's where we find the roots, right? Everybody remember that? What's another word for roots again? Instead of roots, what do we call this? We call this the solutions. Everybody with me? What is another word for solutions? When it cuts the x-axis, what do we call that? The x-intercept. So all of these things represent, I remember it's always two. So how do we write it? X is equal to the first one, or x is equal to the second one. Remember, if there's a quadratic, it always got two answers for x. Everybody with me? No, these are things that we need to remember. Anybody remember linear programming? What does linear programming means? So let's go to the side. Remember, linear programming is when they're going to give you sentences like X, you have X represents apples and Y represents oranges. There are more apples than oranges. So you know the first equation going to be what? X is greater than Y. Everybody remember that? And then they're going to say the cost of one apple is 50 cents. So how do we write that? 0.5x and the cost of one orange is 75 cents. So it's 0.75y, right or wrong? Then they're gonna say, we don't want to spend more than $50. So what I mean, 0.5x, which is the amount of apples we buy in, plus 0.75y, which is the amount of what oranges, should be what, less than or equal to what, $50? Everybody remember that? And then they might give us another sentence that we write as an equation. And then they're going to say, use the graph to solve. How do we do this again? Anybody remember? We know how this line look. What is the x equal to y line and the y equal to x line? How that line look? Then the line like the diagonal. I'm just doing a quick demonstration. So you know that you can always use the equal line. So the equal line is, oh, and sometimes it'll say, I bought more than 5 apples. So that would be what? X is what? Greater than 5, right? And then they might say, I bought less than 10 apples. Y is less than 10. So everybody see how we get we inequality. So let's remember how to draw these things. So the first line, how this one gonna look? We're gonna first draw the y is equal to x line and the x is equal to y line. That line is the diagonal line. Everybody remember I spoke about that in the matrix transformations? No, because x is greater than y or y is greater than x, where are we gonna go? Above or below? Which side represents x is greater than y? The left or the right? Come on, everybody, try, because we did this already. Excellent, because x is greater. This side is where x is greater. So where we going to shade? We're going to shade over here. Everybody remember that? Then let's look at the next line. X is greater than 5. What type of line is this going to be? A horizontal or a vertical? Remember, we're going to first start off by writing our x is equal to y line first. So let me see if anybody remember that. What type of line is this? X is equal to 5 is what? A vertical or horizontal? Excellent, a vertical. So we're going to look for where 5 is on x. We're going to look for 5 on the x-axis, and we're going to draw a vertical line. Everybody see that? And because they say x is greater than, what side we're gonna shade? We're gonna shade the left or the right? The right. So all here we shading. Everybody seeing it coming together? So everybody seeing the areas we should be paying attention to? Remember, this is just a sketch, eh? Let's do the next one. Y is less than 10. Is this a horizontal or a vertical line now? Mom to everybody else, only certain people answering. Y is equal to 10. So we got to draw the Y is equal to 10 line. Hey, patience, stop touching my board, fams, before we war, sis. Horizontal, excellent. So I'm going to look for where 10 is on the line. 10, right? And I'm going to draw my horizontal line at 10. And because it's less than, we're going above or below? Below. Excellent. Everybody seeing the area we should be looking at already? That in the area where all three covering the same space. Everybody see what I'm saying? Then, when you have an equation like this, how did I teach you to answer your equation? How do you know how to draw this line? Anybody remember when we had to make x is equal to 0? make x equal to 0 and then solve, and then make y into 0 and then you solve. So let's do this. When x is 0, this is 0, right? So we're going to end up with 0.75y is less or equal to 50. So we divide by 0.75. Somebody divide this by 0.75 for me. Remember, just making up numbers, so we might not get a whole number. So talk to me. What do we get? 50 divided by 0.75. So let's round that after a whole number. Let's call that 67. So y is equal to 67. But let's just pretend like it's just a 6, a 7. Everybody see what I mean? So what is the first point that we're going to plot? 0, 7. Where 0, 7 is B? 0, 7 is like here. 7 below 10. Everybody see that? Then you're going to make y is equal to 0. When y is equal to 0, you're going to get 0.5x is equal to 50. So x is equal to 100. So what's the second point? 100, 0. So that's going to be somewhere like 100, 0. So then what you're going to do once you find those 2 points? You draw a line. Everybody with me? So let's go again. Remember, we know there's some basic lines that we know. We know like y is equal to x line, that's standard. We know how to draw any horizontal vertical lines when x is equal to a number that's a vertical line, sorry. When y is equal to a number that's a horizontal line. And then you just know whether to go above or below. And then when they give you an equation, what do you do when they give you an equation? You make x equal to 0, you find that point. You make y equal to 0, you find a point, and then you connect those 2 points. Now, if I was to try solve this, I would focus on the area where all 3 graphs cut, which would be like in this area here. Everybody understand? So what you would do is read the graph and find out what point is this. Read the graph, find out what point is that. Read the graph, find out what point is that, and then you answer the question that they ask you for. So this is something we've done before. That was just a quick recap of linear programming. Okay? All right. The next thing that we have to touch on is the time travel graph. Everybody remember the time travel graph? And remember, it's 2 different graphs. One is speed and one is acceleration. Everybody remember the difference of speed and acceleration? So for this one, this means no movement. And on this graph, this means a steady speed. That means no increase or decrease. Everybody remember that? If you don't remember that, do your revisions because I gave you guys the notes and questions and the handout. Okay, it's inside your blue book. All of it is in the blue book. Okay. Something that you need to remember is if you're using the acceleration graph and it's a calculate the distance, you just find the area under the graph by breaking it down into different shapes. So you know this is length times width. You see how much this is, you see how much this is. Then you do another shape. This is a trapezium. This is another trapezium. And this is and then you add up all of them to get the total distance, area under the graph, okay? All right. So my suggestion is for this question 8, another thing is, remember the table? Tell me if you know what I'm talking about. When you got your x and your y, and then they give you like a 3x squared plus 2 minus 6. Everybody remember that? They're going to give you the function, so f of x, and then they're going to give you like -1, 0, 1, 2, 3, and then they're going to tell you complete the graph, the table, and you know how to complete the table, right? What numbers you're going to put inside this formula? You start with -1, substitute in your answer, you put here. Then you put in 0, you calculate it, you put your answer here. You put in 1, you calculate it, you put your answer here. Then you put your answer here. So what type of curve, what type of thing you get when you draw this in a curve? Is this going to be a maximum curve or a minimum curve? How this curve going to come out? Hello? If you don't know, just say, somebody said maximum. Wrong. What is A here? What is the value of A here? A is 3, A in positive. What do we know about when the curve, when it's positive? When A is positive, what I mean? When no, it's the opposite. So if it's a positive curve, that means it's what? Minimum. When it's negative, when A is negative, it is a maximum. So see, we gotta try remember these things, right? All right. So everybody remember how to find the line of symmetry. You find the halfway between the two. You draw your line and you know how to find the equation. So if this number is 4, what is the equation of this symmetry? X is equal to 4. How do we find the minimum value, the minimum point? We just look for where the curve go down and we measure these two things that will give us our maximum and minimum point from off the graph. How do we find the roots, the solutions? That's where we find these two things. So everybody remember when we did a question just like that, with several questions just like that? So you have to do the calculations and then you have to plot your own graph and then find all the information from the graph. Because remember, these questions always come in calculation method. Let me just scroll in here. Calculation method or the graph method. So that's question number 8. Question number 8 is a lot, but once you could at least try to remember those elements, you should be fine. Okay, everybody, okay, how you feeling about question 8? Give me your rank. That was just a quick revision. I'm looking. Remember, you're trying to get as much marks out of 8 as possible. I don't expect it to be your strongest topic, but I expect you to be able to, yeah? Something I want to pay attention to here. Y'all remember when I taught y'all this? Whenever you square root a square number, your answer is 2 options, a positive and a negative. Don't forget that. So if you square root 9, the answer is not just 3. It's either positive 3 or negative 3. Why? Because negative 3 times negative 3 is also 9. 3 times 3 is also 9. So it's 2 answers you could get, either positive or negative. If you got it, you got it. Oh, sorry. All right. So that's question 8. Now we're going on to question 7, investigation. I left this blank because I'm going to do a quick activity. Everybody remember how to find the nth rule? So I'm going to do a question and everybody can find the nth rule for me. 5, 10. Shit, sorry. That's not it. 2, 7, 12, 17, 22. Find the rule for this for me, please, everybody.
Ready? Oh, you can some.
What's the rule? What's the nth rule? I expect everybody to be very strong in question 7. So I expect everybody to send me the answer for this. That's not correct, Gav, with the rest. That's not correct either, Arabo. Things not looking well. Everybody, let's go patience. Okay. Excellent, that's correct. One to everybody else. What's taking so long? This is something I expect everybody to go unlock. What's going on? So what's the first thing that we do here? This is not good. I'm not happy about that. I expect everybody to be strong in question 7, and this is just the linear version. So we gotta get together. This is unacceptable. The first thing we do, what's this pattern here? And if we're not gonna communicate, I would end class right now and go lay down. I literally here with you guys. So I need everybody to be talking and communicating and participating, please. So let's go. What is the pattern here? So the pattern is +5, right? So what does that mean? The base of our formula is what? The base of the formula is 5n. Well, we should know, what does 5n mean? 5n means we deal with multiples of 5. What are the multiples of 5? 5, 10, 15, 20, 25. But we don't want 5, we want 2. So how do I go from 5 to 2? A -3. How do I go from 10 to 7? -3. 15 to 12? -3, -3. So what's the final formula? 5n -3. Hello? Moving on again. Next example. Find the formula for this. Wrong. What's the pattern here, everybody? What type of let's do this here together. How do I go from 5 to 11? How do I get 6n plus 1? Plus 6. How do I go from 11 to 21? Come. Answer the question. How do I go from 11 to 21? Plus 10. 21 to 35. Plus 14. 35 to 53. Plus 18. What I mean, if these numbers don't match, what does that mean? Somebody said it earlier. So that means we got to go again. How do I go from 6 to 10? 10 to 14. 14 to 18. So what do I do with this 4 now? Wrong. It's 2 steps, so I can't just use 4. It's 2 steps that I did. So what you're supposed to do, you can't go again. You don't got a constant number. That means we're not studying the way we're supposed to be studying. What do you do with the 4? Somebody got to remember, because else that's it. Thank you. You got to divide by 2 because it's 2 steps. So you're going to say 4 divided by 2 is equal to 2. So what is the base of my formula? It's quadratic and you're using 2. So what's the base of the formula? 2n squared. Thank you. So let's go now. What do I do with 2n squared? I got to find 2n squared for all these here. So I got to find when n is equal to 1, n is equal to 2, n is equal to 3, n is equal to 4, n is equal to 5. So let's put in these formulas. When n is 1, what is the answer? We're substituting into the base of the formula. Just like how we were substituting into the base of the formula 5, 10, 15, 25. What's the first number if I substitute 1 in here? And that's a question for everybody. So if majority of the class don't answer, I am in class right now. So the first term is 2. What's the second term? This is a basic substitution thing. I'm not doing this. So what is the second term? You're substituting 2 into the formula now. Not correct. 2n squared. What is 2n squared? If n is 2. Try again. Not correct either. Nadia is correct. 1 to the rest of the class. Everybody else, what happened? You don't have a calculator. You don't have a pencil to try work it out. What is the problem? Why more people not trying? If you scared of my reaction to today, might as well you leave class right now. Because what I'm asking of you is nothing that's beyond your capability. If n is 2 and I substitute n into this, what do we know about BODMAS? We're going to square first. So we're going to say 2 square. What is 2 square? 2 square is 4. And then we multiply that by the 2 in front. 2 times 4 is 8. So everybody, let's go. What is the value when n is 3? And I'm being very serious this time. If more people don't answer this next question, this is useless. And I'm wasting my time and energy. So what is the answer when n is 3? Zahira may see you post nothing for the night, by the way. Rakaya may see you posting nothing night all. What going on? 18. Next one. Move faster. What's the next one? And the thing is, why am I frustrated? This is square numbers. If you can't square numbers and then multiply by 2, but don't go to the exam, you know. Don't go to the exam. Because everybody should know 1 square is 1 times 2, that's 2. 2 square is 4, 4 times 2 is 8. 3 square is 9, 9 times 2 is 18. 4 square is 16, 16 times 2 is 32. So what's the last one? Come quick. What's the last one? They ain't seen Dante try this night, though. I'm telling everybody, let's go. Javin, you ain't tried nothing yet since you're in class. Good, because 5 square is 25, 25 times 2 is 50. So what is the next part of the formula? So we know the base of the formula is 2n squared. What's the rest of it? How do we get the rest of it? How do I move from 2 to 5? How do I move from 8 to 11, 18 to 21, 32 to 35, 50 to 53? That's it. If you don't know how to do this, I don't know what else to say again. Because that's something, honestly, I'm disappointed that y'all can't remember. Because what did we say our top question should be? Our top question should be 1, 2, 4, 5, 7. That's the top 5. They're supposed to be a strength today. Then the rest of the questions require you to do what? To use algebra to substitute. So for example, hold on there. So for example, if you had a table, so this is our table, right? So we had these numbers 2, 7, 12, 17, 22. And if I had a number dash, and then let's say the formula is 5n minus 3. And then I had a number here dash, and I put here 10. So this is your n. So this is 1, 2, 3, 4, 5, and this will be 6. And then you got your dot, 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 dot. Let's do this one here together. How do I get the answer for 6? What's the answer for 6? We don't identify that the rule is what? Plus 5. So how do I get the next term? What's the answer for the next term? And if you don't answer, I'm kicking you out the class. I'm going to remove you from the class because why are you here? So I'm looking at the chart and I want to see what you think the answer is. What's the answer for when n is equal to 6? Come to everybody else. Who else I need to remove? How did we get out? All we had to do was what? Just continue adding 5. So you get 27. How do I work out this answer here? What do we do? Is a S word. What's the S word? Substitute, because we have the formula, right or wrong. So all we need to do is put what? 10 inside this formula and work out the answer. So what's that answer? Excellent, 47. No, suppose this though. Suppose you got a formula. I'm just making up something right now, okay? I'm just making up something. Suppose now we have a dash here. And then suppose you have the answer. How do you find n in this case? So you know the answer is 97. What do we do here? What is the approach to find how much is n here again? Excellent job, Dante. That is it. We take the formula, we make it equal to 97, and then we transpose. So we have 5n minus 3 equal 97. And then we do what? We carry this over. So 5n is equal to 97 plus 3. So 5n is equal to 100. And then what do we do next? We divide by 5 on both sides. So n is equal to 20. Everybody remember that? So that's how you complete the table. And then in the end, they always give you like a worded problem. And I've taught you how to write worded problems. You write the information they give you, and then you decide whether you got to transpose, and highly likely you got to transpose to solve. All right. And that's it for question 7. I also taught you guys how to finish and answer the diagrams, how to find the missing patterns. So that's question 7. Question 6, we're skipping. I ain't even got energy for this right now. This should not be here. This should be question 4. This is question 4. This is question 4. Hold on there. Give me a minute. Let me fix this. Guys, you want us to continue and go straight up till 1? I'm willing to continue going straight until 1. Is this useful? Is this helping? Is this bringing back the things that you should know? So give me a minute. This should be by question 4. Yeah. This should be by question 4. Okay. So let's do question 5 together. I like how I did the notes for question 5 in the blue book. So anything that I miss here would be in the blue book. But let's go through this here quickly. If you're ready, say ready. If you're ready, say ready. So we reach halfway. We are question 5 because you know we're skipping question 6 and nobody gets in for that. But it's just we still put on. All right, so let's go. First thing first, everybody remember the different types of data, right? We know the raw data, the ungrouped data, and the group data, right? Everything is not on this, but everything is in the blue book. So I'm gonna try to see if I could get everything on this paper because I was trying to finish, but I just wasn't feeling so good, so I didn't get to finish. So bear with me, okay? All right. So as I was saying, you should know, we did this at the beginning, you know, qualitative data is when they talk about properties of data. So like your height, what color you be, them kind of things there. But quantitative deals with numbers. So like shoe sizes, height, weight, all of that stuff, right? Now, we know the difference between, we're going to go straight into the group data. So you know what's the limit. So if I have, this is a class, or what is another word for say class? Interval. Everybody remember that? Another way to say this is interval. So you should know who's the first interval, the second interval, the third, the class, all of that. So as I was saying here now, so if this is the interval and the actual lower limit, you know the limit is always the beginning and ending numbers. So the limit, lower limit is 150 and the upper limit is 154. But then we remember about the boundaries. What's the boundaries? The boundaries have what? 0.5 before and 0.5 after. Everybody remember that? Then we got a class width. Remember the class width, you got to use the boundaries. The class width means how much numbers is from 150 to 154. So you could count it. If it's a small gap, you could count it. So 150, 151, 150, 152, 153, 154. How much is that? 1, 2, 3, 4, 5 numbers. Everybody see that? If I had subtract, you realize we would have gotten 4, and that's wrong. If you got it, say got it. So that is why you can't use the limits. You have to use the what? The boundaries. If it's a bigger gap, you can't really count all the numbers. Counting all the numbers would take too much time. So it's the upper boundary minus the lower boundary to find the class width. Class width just means how much numbers from the beginning to the end. All right? Okay, so everybody okay with this? Everybody remember that? No, I made a mistake here. The histogram is the frequency should always be on the Y. I don't know, like I was sleeping or something. But what information we need? On the X-axis, we always use the upper boundary. And on the Y, we always use the frequency. And then you remember that the histogram always touches each other. This is how it looks. If you got it, say got it. Then we know the frequency polygon. What information? You see, I make the mistake here again. I don't know what was going on. Tell I wasn't feeling good. But what do we always use for the frequency polygon? We use the midpoint on the X, midpoint. And what do we always use on the Y? What do we always use on the Y? Somebody, the frequency. But then what do you remember? Remember when you draw it, right? It's gonna always, if they give you the endpoint, it's gonna always look like this. And what do you have to always do? be sure to close the polygons with the midpoints at both ends. So you got to find the midpoint. So if the midpoint they give you ended here, you remember the midpoints always got like a pattern. It's always like +5. So if you need to find the next midpoint, all you got to do is what? And just add 5 to the last one. And then how do you find the midpoint before? You just subtract my 5 from the first one. So what do I mean by that? Let's look at this. Suppose these are our midpoints. 3, 8. Let's start with 8. 8, 13, 18, 23. So let's say these are the points that we plot. This is the midpoints. How do I close it? What will be the next midpoint that we got to bring down to close it? Somebody? Anybody? What? The N1, the last one. So that means we're going to close it down at 28 because we got to add 5, right or wrong? I see where you said 3, but you got to answer the question I asked, right? And what is the midpoint before that we got to find in order to bring it down? So this is how we're going to close it to the line. So it would close at 28 and wherever. And then where does it close in the beginning? We got -5 to get 3 and we close it down here. Everybody see that? This is our frequency polygon. If you got it, say got it. All right, let's look here. Then something missing. Where's the cumulative frequency curve? Let me do that first. Okay, then we have our cumulative frequency curve. Everybody remember how your cumulative frequency curve should look like this? Everybody remember that? How do we find the median? How do we find the median? If this is 100, where would the median be? The median would be at 50, right or wrong? Let me use a different color. So median would be at, this would go straight across here. So if this is 100, the median would be at 50, which would be here. So we carry cross, let me zoom in. You carry cross your line and you bring it down, and this would be, that number here would be a median. How do we find out how much every small box is? Remember, if you're counting in 5, so that's 5, 10, 15. How do I know how much small box is here? We take the number, this number, what is this number from here to here? Here is 5. How much box is here? 5. So it's going to be 5 divided by 5, so that's 1. Everybody see that? If it was counting in tens, it would be 10 divided by 5. If it was counting in 20s, it would be 20 divided by 5. Everybody got it? To find your small box? Because remember, you got to count each box to this accuracy. So as I was saying now, that's how we find the median. So what does these other two numbers represent? Anybody remember? They are called what? The quartiles. So we find half of the half, and in this case, that would be what, 25? And so we bring it down, that's quartile 1. And then if we add the 25, that would give us what, 75? That would be quartile 3. Why do we need to know the quartiles? Because what do we remember the interquartile ranges? Where is that? Look at him. Formulas for the interquartile range. Everybody see that? So the interquartile range is Q3, which is the upper quartile. Sorry, let me use red. Upper quartile minus the lower quartile for the interquartile range. And then what do we remember semi means? Semi means to do what? Semi means to divide it by 2. Everybody see that? Hello? Okay, so let's look at some other information. What does range mean? Range means the highest score minus the lowest score. So if in the table, you got shoe sizes, and the smallest shoe sizes is 5, and the biggest shoe size is 10. What is the range? The range is 10 minus 5, so that's 5. There's 5 different sizes inside of the sample. That's what range is. We did that. So let's talk about mode, median, mean. What does mode mean? Mode means the most popular, highest frequency. We learn how to find the median 3 different ways, right or wrong? Remember, we found the median using raw data. And what do? We put from smallest to biggest, and then we find the number in the middle. Everybody remember that? The same time as all other government office, 8 o'clock. Then if we had a table, everybody remember how to find the median from the table? If I have 50 people in the sample, 50 is what? An even number, right or wrong? So you can say 50 divided by what? 2, which is what? 25. So where would I find the median? Because it's even, it's 2 numbers. So we're going to find the number in the 25th position and the 26th position, right or wrong? Everybody remember that? Hello? And if it's odd, so if I had 41 divided by 2 is what? 20.5. But we're going to round it off to what? Instead of 20.5, we're going to look for which position? We're going to look for the 21st position. So we just need to find one numbers where the number 21st position fall, and that is the category. That is the number. Why would you divide by 2? It is odd. Remember why we divide here by 2? Which one you mean? The 21st? Yeah, that's how we get 20.5. 41 divided by 2. That's how we get 20.5. When you find these two, yeah, that's the one you divide by 2. Yes. Because you remember it's 2 terms, she's correct. When you find them 2 numbers, you add them 2 numbers and you divide by 2. Everybody remember that? Because if you got 2 numbers in the middle, what you just do with them, add them and divide by 2. So it's the 25th and the 26th, you divide them by 2. But because it's odd, you only need to find the 21st position. Everybody remember that? Hello? Also, everybody remember this formula here? Where it is? The mean formula. Look at it here. F times X divided by sum of F. When it's raw, you add up all the numbers and divide by how much numbers it has. That's raw data. And for your group data is the same thing, right? If it's group, you're going to find midpoint. X is the midpoint. But if it's ungrouped, X is just, they just give it to you. They can give you your F values and your X values, and then you multiply them to find Fx. And then you add up. So you add up this, you add up that, you divide them. Everybody remember that, right? Talk to me, talk to me, talk to me. Something else we did is the pie chart. Everybody remember how to change anything to a pie chart? So if you have students, you put it over the total, each category, and then you multiply by 1. Anybody remember how to find the degrees, the angles? What do you multiply to find the degrees? You multiply it by 360 over 1. So if you have 10 girls out of 30 girls, out of the class of 30, that's the angle for girls. If you got 7, whatever. All right. I think everything else we know how to do. So that's question 5. Let's do question 4. Everybody remember the different types of relations. What are the different types of relations? 1-to-1, 1-to-many, many-to-1. 1-to-1, many-to-1, 1-to-many. You know which ones are the functions? 1-to-1 is the functions, many-to-1 is the functions, and this one is not the function, right? What do we also know? How does the ordered pairs look? Ordered pairs is what? Your X and your Y, your X and your Y. Who is the input? X is your input, and you calculate your Y, which is your output. Everybody remember that? All right, how do I find f of anything? If I find f of 0, that means what? Everywhere I see x, I'm going to put what? 0, you substitute it and you calculate, your answer will always be a number. If in here's a number, your answer is always going to be a number. f g of x. What does this mean again? What type of function is this? Composite. Who is inside of who? G is inside of f. So I'm going to do a quick example. If I say f of x is equal to x plus 2, g of x is equal to 5x minus 1. Suppose I tell you find f of g of x. What's the first thing you're going to write? You're going to write the model, which is what? X plus 2. Since the f of x is equal to x plus 2, so that means f of g of x. Who are we replacing here? Everywhere we see x, we're going to replace it with what? G of x, right? So that's going to be, instead of x, what we're going to write? G of x. And then we put back the what? Plus 2. From here, what do we write? We just write out what g of x is. What is g of x? 5x minus 1, right? And then we add back what? Plus 2. From here, it's just algebra. So what's our final answer? 5x plus 1. Because negative 1 plus 2 is positive 1. Everybody remember that? Hello? Then, what is the steps for finding the inverse? What's the steps to find inverse? Let's go step number 1. Express as x and y. So instead of having f of x is equal to that, you put y is equal to that. What is step 2? Switch or interchange x and y. So wherever you see y, you put x. Wherever you see y, you put x. What's the third step? Make y the subject. Once y is the subject, you just rewrite it. F inverse is equal to x minus 2. Everybody see that? Hello? Remember the same thing here that we did with the composite functions? What does this mean? What does f squared mean? F means what? You're putting f inside of f. Everybody remember that? So g squared means you're just putting g inside of g. What does it mean for a function to be undefined? So let me give you this, right? X plus 2 over x minus 1. What makes this undefinable? What's the value of x that makes this undefinable? That means that it is undefinable if the denominator is equal to 0. What number must x be for this to become 0? I did this a million times. I literally, every other class, once we talk about functions, I literally ask the same exact question. What is x? If x minus 1 is 0, what is x? And I hate when y'all do that. I hate when y'all don't even try. If you're fearful of my reaction, like I said before, might as well leave class because me don't understand. What is x? If x minus 1 is 0, what is x? And what annoying me, but are you? Why the question mark? Who you asking? You telling me or you asking me? You're gonna ask the exam if it's 1, or you're gonna tell the exam is 1? You're not gonna eat all your food because me know why y'all asking me that. What will give you 0? We know 0 is the identity for addition and subtraction. So how do you get 0? You ain't subtract yourself. So if I am subtracting 1, who am I gonna subtract from 1 to get 0? 1 without the question mark. Everybody understand what I'm saying? Hello? If you're not going to go in the exam with confidence, you're going to struggle. So I'm going to give you a harder version of this, and I want you to tell me what X is. And I'm watching the people who still not even trying to respond, still not even trying to think. And again, I noticed something about some of you. Some things seem a little hard. The first thing you're going to say, I don't understand. It's not that you don't understand because you learned it before. It's just that you're unwilling to think. And if that's the energy you're going into the exam with, I'm telling you, no, that's it for you. You have to go into the exam mentally prepared to think. The exam is 75% thinking, 25% knowing. I don't know how much more I could say this. So look at this example. X plus 4 over 2x minus 1. This is different now, right? What makes this undefinable? This is a whole equation, so I can't just look at this and guess. So what do you think I need to do? I got to say 2x minus 1 is equal to 0, and from there do what? What do I do from here to find out what 2 is? X is? Everybody realize it's always transpose. If they say that this function is undefinable, that means that x is the denominator is 0. Anybody remember the time when I divide numbers by 0? What your calculator tell you? What did your calculator tell you? In error. That's what it means to be undefinable. It's undefinable if your calculator cannot produce an answer. It is not possible to divide by 0. That is why if anywhere, and this don't only come in function, this could come anywhere. If they ask what makes this equation undefinable, it means that the denominator is 0. So that means you put a denominator equal to 0 and then you transpose. So if I carry this over, there's going to be 2x is equal to positive 1 divided by 2 divided by 2. So that means x is a half. So that function is undefinable when x is a half here. The example before, this is undefinable when x is equal to 1. Because when x is equal to 1, the denominator becomes what? What does the denominator becomes when it's undefinable? What is the denominator if the function is undefinable? 0. Thank you very much. No, the only thing we have not done here that I would like us to do is a question like this. If f of x look like this, what type of function is this? Is this a linear function? So we're going to use this exact example. So if I say f of x is equal to x plus 2, x over 1, is this a linear equation? Is that a yes or no? It's only 2 persons responding. Excellent. How do we know it's not a linear? Because what do you realize? There's a x in the numerator and the denominator. So this is called a what? This is actually a quadratic. Well, a non-linear. Should I solve this? Should I find the inverse of this? Should I remind you how this look? How to work this out? Only one person in here got manners, you know, but saw your face. Okay, let's go. So everybody paying attention, right? If you locked in, say ready. Okay. So we know the 3 steps, right? What's the 3 steps again to find inverse? You write in terms of x and y, right? Then you do a switch, and then you make y the subject. It's the same 3 steps, except for one difference. So let's take a look at that. So we're going to say y is equal to x plus 2 over x minus 1. That's step 1. Step 2 is what? Switch, right? So what does it become now? It's going to become x is equal to y plus 2 over y minus 1. Anybody remember what's going on here? Anybody remember what you're supposed to do when you got something above and below? You're supposed to cross multiply. Anybody remember that? So you put this over 1. And this is not just for this. Anytime you're trying to solve anything, even in algebra, and the thing that you want is both in the numerator and the denominator, you cross multiply. Everybody with me? So let's go. When I cross multiply this, what does this become? X open bracket y minus 1. Why did I put it in bracket? Because this is 2 things. Everybody remember that? Equal 1 times this is y plus 2. So let's pause here. Everybody with me so far? What do you do next? What's the next step? Anybody? What's the next step? And from here, to be honest, because what I'm doing now is actually making y the subject. Because we done switch, right? So we're making y the subject. Excellent. Everybody agree? Do we do brackets? Because now we need to make y the subject. So that means we only want y on one side. Talk to me. Do we agree? Because everything from here is basic algebra skills. So you must know your signals. Signals are things that you should see that should tell you what to do next. Should trigger your mind to tell you, okay, that means I got to do this next, and then this next, and then this next. So bracket. So let's go. What do I get? X times y is xy minus x times 1 is x, y plus 2. What would you do next now? Remember, what's this step? Make y the subject. So what should I do now? What would make more sense? If I want to make y, transpose how? You gotta be specific. How do I transpose? What are we trying to transpose this to make this look like? Yes, but what is the point? I agree. So when you move x, why you move x? Why you didn't move the xy? I'm trying to make sure you understand the why. What do you do next? Why? So both of you are correct. We do move the minus x, but what is the point? What are we trying to accomplish when we transpose in this example? If we're trying to make y the subject. This is the kind of thoughts you're supposed to be having, guys. Anybody? What does make y the subject mean? Put y on one side. Excellent. Then the point. When you're making something the subject, then the one you want on which side? What side do you want that on? The thing that you wanted the subject, everybody, what side do you want it on? So that means we want everything that having a y to be on our left-hand side, and everybody else gonna go where? Everybody understand the point I'm trying to make? Because if you don't know why, how you gonna know what to do? And that's what I've been teaching y'all from the jump. Making something the subject means that it is at the forefront and everybody else is equal to it. So that is why the minus x got to move. And that means somebody else got to move too. Who else got to move? The y got to come over. Everybody with me? So let's do that. Keeping in mind, because it's addition and subtraction, we're just moving across the equal sign. And when we move across the equal sign, we know the sign changes. So we have xy, which stays. Xy, oh, God. This is not the time. Just trying to get my pen to work. Hold on. Okay. So xy stays. Who comes over? So this becomes minus y. Everybody agree? Equal. You realize the 2 was there first, so the 2 stayed. And then who came over to meet the 2? The plus x came over. Now, this is the part now. Look at this. What do we want? We want y only, but y caught up in something. Who will remember how to get y by itself? There's a F word. What do we do to get y by itself? Because we've done this several times. Excellent. We factorize out y. What type of factorization is that? When they have something in common. Distribution. At least one person answering me, It could have been more, no, so thank you very much, Kavisha. Big up all the ladies trying. Thank you very much, Raquel. Thank you, everybody in the DCL, everybody who trying consistently engaging, Arabo, Rainbow. Who else was talking a lot? One to everybody else. Everybody else just going quiet. They're not trying. But what to do? So we take out the y, and when we take out y, you know, you're dividing by y, right? So what left back? This is important for everybody to tell me. What left back? We're gonna go inside the brackets. X, yes. X minus 1. Excellent. Because y divided by y is 1, equal to 2 plus x. What is the final step? We want x alone. So what's the last step? Anybody? We are almost there, guys. I just don't want to, but before you cancel, you got to do something. Exactly. You got to divide to cancel. And you're dividing by this bracket, right? And whatever you do on one side, you do on the other side. Anybody remember us doing this? So that cancel. So y is equal to 2 plus x over x minus 1. So that's the only thing I did from scratch because I know some people don't remember. So this is the difference. So what is our final steps? So therefore, f inverse is equal to 2 plus x over x minus 1. If you got it, you got it. All right. So when it comes to question 3, I don't have everything here, but I just say, is that okay? Remember the things that you should remember. So these are the things we need to remember for these transformations. You know what's the best way to revise this? Everybody remember the compilation we did on question 3? I think I have our papers online. When did we do that? Remember when we did it? When we did the when we was practicing in class with the graph paper, how to do the bisection, how to find the midpoint. I remember that? How to find the center of rotation, how to I know how to do the enlargement lines. I know I did this, eh? I can't do this in class today. So what the only thing I won't do in class that you have to do on your own is that. So what I'm going to touch base on is the things that you should know how to describe each, but in terms of the actual notes for that, you have to use that exam, okay? So let's go into question 3 quickly. Sorry. Guys, give me 2 minutes. Read through this. And I'm going to tell her what's the most, you see this here? This is the most important thing that you need to memorize. Hold on it in red. How to calculate the angles inside any polygon. The formula for the internal and external angles. These two formulas here. Hold on. I just need to get some more water. Hold on. Yeah, can see? Question, y'all okay to finishing? Because we reached question 3. And I would like to finish everything at least tonight so that tomorrow we could just focus on anything that you realize you want us to do more of. So even though it's 7:31, y'all willing to continue? Okay. All right. So just take a look at that while I try to do something here quick and then we finish. How y'all feeling though? Like, anybody feel like they're getting closer to being ready? No, this is something I'm gonna be honest with you in. Right now, you don't have time to focus on like negative thoughts. Right now, what you need to do is you need to go into hyper gangster mode and be like, I can try to get as much marks as I can as possible. Just a heads up, when it comes to paper one, I literally doing these online compilations. You see how for paper two, I put all of question one together, all of question two together. I literally took 5 to 8 exams and I put in one test, in one quiz, every question that could come under number theory topics. And remember, what you know about paper one question is do or repeat. So once you do it once or twice, it would make it easier for when you do the whole paper in general. Everybody understand what I'm saying? I literally stayed up last night and tried to finish. I did 3 exams last night and today. So after class today, I'm gonna try to add on at least 3 more so that as soon as we finish, because we're not gonna do any face-to-face class until later on, until we finish all the online versions. And then the other ones, we're gonna do it face-to-face as a practice with time management. So I feel like we're going to be very, 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 very good with paper one with this new strategy. So the point about paper two is just to try to get as much marks as possible. And what's the 4 steps that we're focusing on? We got to know the formula. Once you know the formula, that's what will empower you. And then you know your steps. Formula, substitution, which is where we pull the information from the graph, the worded problems, we write it out, and then we substitute, we work, and we answer. Okay. Once you think along those lines, you're gonna be perfectly fine. Almost finished what here doing, and then we could go back into the but how you are feeling? Talk to me. Oh yeah, I saw a question come on proportion. So can we touch that a little too, please? Yeah, that's question 2. That's the next topic. Also come tomorrow with your list of anything you want me to. You see like how we gone through everything tonight? If you realize there was an area that you're not so confident in, um walk with that tomorrow. So tomorrow I should be feeling, hopefully I should be feeling a lot better. I will confirm with you guys because either way we can have class, whether face to face or um online. So I'm gonna let you know if I feel well enough to do face to face by 12 o'clock. I like that attitude, patience. I like to hear that. I love to hear that actually. That's what we're talking about. Yeah, go hard or go home. Exactly. Very good. Almost finished. Just a couple more seconds and we start back again. This feels so sick and nauseous. All right, guys, ready again. So we're just gonna run through these here quickly because I think I'm gonna leave out question 2 or maybe touch on it a little bit and then we focus it on that one. So if you're ready, just say ready. I know it's just 7 of us left back here, but if you rocking, I rocking, right? Sorry. Ready? Ready? All right, so let's go with those who ready. All right. Ooh, I feel so awful. Okay. So as we know, we're gonna go through this quick. Complementary, they add up to 90. Supplementary add up to 180. And you know that's a straight line. And you know we use the word supplementary to describe anything that add up to 180. That includes triangles, right? Then we have angles at a point. You know, all angles at a point add up to 360. Everybody remember vertically opposite? Vertically opposite happens when you have an intersection. Anytime you have an X anywhere, the two opposites facing each other are equal, right? And then everybody remember the Z and you know all the different angles affiliated with the Z. You know they got to corresponding. What does corresponding mean? Anything that hold the same position are equal. So A, B, B, C, C. So that's corresponding. And then we know we got we alternate angles, which is the Z shape. Keep it in mind. We also have the backward Z. So this B is equal to this B. Then we have the co-interior. Everybody see the co-interior? Both of them add up to 180. We know angles in a triangle add up to 180. We know angles in a quadrilateral add up to a 360. Everybody remember the internal and external angle? How we find the external angle? Remember, both of them are on a straight line, so both of them would add up to 180 degrees. Yeah, if you got it, say got it. Everybody okay? Everybody know all of this? Everybody lock this down? Okay, then we have all the different types of angles: acute, right, obtuse, straight, reflex, full turn. Then we know our different polygons: triangle, quadrilaterals, pentagon, hexagon, heptagon, octagon, nonagon, decagon. Now, this is the part I want us to make sure we got unlocked. You could calculate the sum of all the angles in a triangle, in any polygon, sorry, by this formula. So it's 180 outside n minus 2. What does n represent again? N represents the number of sides. So if it's a hexagon, what is n? If it's a hexagon, what is n, everybody? Hexagon, very good. So you just substitute and I'm going to give you your answer. If they want to find the sum of all external angles is equal to 360. Okay? So if you want to find out how much is the size of one external angle, it's supposed to be 360 divided by n. Everybody with me? So the external angle for all polygons is 360. So if you want to know the size of one, if you got n sides, if you got 6 sides, you divide it by 6. That means that the external angle for this is 60. Everybody with me? All right. Then we got a different types of triangle. You have the equilateral, all sides angles equal. Yeah, I'm feeling worse. Okay, that's okay. Then we got the 90-degree angle, which is the right angle. We got the isosceles. We got the scalene, which no sides equal, no sides equal. Everybody remember all the different type of quadrilateral: square, rectangle, parallelogram, rhombus, trapezium, right? Yeah. So let's just touch on the transformation quickly. What's the tree transformation for? Translation. Everybody remember how translation look, right? It's just like you slide the object either up, down, left, or right. How do you describe a translation? You give the vector. You give the column matrix. Everybody with me? So that's how you describe a translation. You say what the X is, what the Y is. What's the next one? The reflection. How do we describe a reflection? What must we state? We must state the word. Anybody remember? You must state excellent. You must state the mirror line. For rotation, what must we state? We got to state three things. What's the three things we must state for the rotation? You must get the angle, the direction, which is anti-clockwise or clockwise, yeah. What else? The center of rotation. Sometimes it could be the origin and sometimes it is not, right? Everybody remember that? Remember, it's not always the origin, eh? It could be somewhere else, okay? Then what is the last one? Rotation, enlargement. What we must state for the enlargement, we must state who is what, K, and we must state the center of enlargement. And I think we practiced this enough for you to be okay. Just use the past papers that we did to practice this. Everybody with me? All right. So we're moving along. I think y'all should be okay with question 3. Question 2, we did last class. We did a lot of it. So let's just quickly go over some of the topics. So you know the laws of indices. First of all, you know your integers, right? Guys, we're gonna got to finish tomorrow. Like I'm feeling like very dizzy. At least we reach question 2, right? Because the last class, we did some stuff with question. We didn't do question 2 in full. I think question 2 was the only class that we actually, we went through all of algebra in it. We did all the skills, right or wrong? We did in our last class, we did go through everything for algebra. So, look the direct variation here too, the fish. So ladies and gentlemen, what you gonna do for me? If you're home, go get something to eat, drink some coffee. So you're gonna finish this for me. You're gonna finish, the only thing we do is consumer. So I think you should focus on this tonight. Since we didn't do it, do consumer for sure. But everything with significant figures and all that, I think you should be perfectly fine. Don't forget these laws, the distribution law, the associative law. So just touch up on these 2 by yourself. Algebra. Sorry. Algebra and question number 1. But everybody, okay, I hope today was helpful. I hope today refresh your memory. And so you just gotta continue pushing and doing what you got to do, right? You got this. Remember, the more work you do is the more prepared you will feel in the exam, okay? You know, I got y'all. So tomorrow class, we're going to continue to just recap. So see you guys tomorrow, all right? Have a good night. Bye.